Hey, grade 11. So going on to part 2 for the solving trig equations with more than one ratio. Going on to example D now. Determine the general solution if cos x minus 4 cos x times sin x is equal to 0. So this one is not like the first example that we did, where we can divide through by cos x to get tan x, and it's not like the other two where we had different angles and we could use co-functions. Okay, with this one we have to do something a little bit different. So as you have a look here, we've got two terms. We've got this cos x term and we've got this 4 cos x sin x term. What I can see here is I have a common factor of cos x with these two terms. Okay, I'm going to take that out as the common factor. So we have cos x 1 minus 4 sin x equals 0. Okay, and now what we're going to do is just like what you did with your equations. If you have something times something equals 0, that will be equal to 0, or that will be equal to 0. So we'll have cos x equals 0, or 1 minus 4 sin x equals 0. Okay, I'm going to solve for this one over here. It's a nice easy one to solve for. So we just go shift cos 0 and we get 90. So we know for the general solution for this one, it's going to be x is equal to plus minus 90 plus k 360, where k is an element of the integers. Okay, I don't have to take it any further than that because we don't have a restriction on our angle. For this one over here, I need to get the trig function on its own. So I take the 1 to the other side and I get minus 4 sin x equals minus 1. Divide by the minus 4 and we get sin x is equal to 1 over 4. Okay, so this one I'm just going to draw a line here just to show that's the end of that solution. This one here, going to use the sine general solution. So I go shift sine 1 over 4 to get our angle. And to one decimal place, that's going to be 14.5. So we'll get x is equal to 14.5 plus k 360, or x is equal to 180 minus 14.5 plus k 360. Just work out what this bit is and we get x is equal to 165.5 plus k 360. For both of these, k is an element of the integers. Okay, and we've solved for that one. Going on to question E. Question E is saying determine the general solution if 5 sine squared x plus 8 cos x is equal to 1. Okay, so this one doesn't fit any of the other ones that we've done because we've got this squared. Now this is tricky when it's got the squareds, because you remember what I told you in the beginning, we want to try and get everything in terms of one trig function. So this is the problem here. And what I'm going to do is I'm going to use our square identities. We know that cos squared alpha plus sine squared alpha is equal to 1. So I'm trying to get rid of the sine squared and to get it in terms of a cos. So if I take this cos to the other side, we're going to get that sine squared alpha is equal to 1 minus cos squared alpha. Okay, and I'm going to replace that with this 1 minus cos squared. Once I've done that, I've got the whole thing in terms of cos. So let's substitute this sine squared to be 1 minus cos squared x plus 8 cos x equals 1. Just distribute the 5 in, so we get 5 minus 5 cos squared x plus 8 cos x. And I'm just going to take the 1 to the other side, and we get that. Let's just get like terms together. So we get minus 5 cos squared x plus 8 cos x. And then that'll give us 4. If you look closely here, grade 11s, this looks very similar to a trinomial. We have something squared plus the something plus a constant. So I'm just going to divide through by the negative just to make our lives easier. So we get 5 cos squared x minus 8 cos x minus 4 equals 0. Okay. Now you remember what I've done before with my little substitutions. I make coses x and sines y. Don't get confused with this x. It is not this x. Okay, I'm just making the coses an x. So we get over here, we get 5x squared minus 8x minus 4 equals 0. This will be a lot easier to factorize in terms like this, except without your coses. Okay, so if we have to factorize this, we would get 5x plus 2 and then x minus 2. Okay, that's how we would factorize that. And I'm going to use this little substitution method to help me factorize this. So this thing now becomes, let's write it over here, 5 cos x plus 2 and then cos x minus 2. Just from this equals 0. Okay. Now, just like any factorization equation question, when you've got these two things equal 0, set the one equal to 0 or the other one equals 0. So we get 5 cos x plus 2 equals 0 or cos x minus 2 equals 0. Okay. I'm just going to work with this one quickly because it's a lot simpler than this. So here we get cos x is equal to 2. All right. Now this one is going to be a little bit of a problem, and I'll show you why. If we go shift cos 2, because that's how we get that x, we get a math error. Okay. So for this one over here, there is no solution. Okay. We can't take it further. So we're going to have to work with this one here. So we get 5 cos x equals minus 2. So that means that cos x is equal to minus 2 over 5. Okay, let's just check this one. So we get shift cos minus 2 over 5. And yes, we are definitely getting an angle, and rounded off to 1 decimal place is 13.6. Write up the general solution for cos. So that's going to be x is equal to plus minus 113.6 plus k 360. K is an element of the integers. Okay, not too bad. So this is question E. All right, going on to the last one, question F. Is asking us determine the general solution if 3 sine squared x is equal to 2 minus sine x cos x. Okay, so again, grade 11s, our little trick making that 1 minus cos squared is not going to help because we still got the sine x over here. We can't take out a common factor and do it like the previous one because then we would still be left with a sign inside the bracket. So that's not going to help. So with this one, we've just got to do something a little bit different. I'm just going to take everything to the one side for now. Make that a plus. And then minus 2 equals 0. Okay, so I want to try and turn this thing into a trinomial. But in order to turn it into a trinomial, I need a cos squared. Okay? And the only way I can see how to introduce a cos squared is this 2 over here is actually saying 2 times 1. Okay? Now we know from our square identity that cos squared alpha plus sine squared alpha equals 1. So I'm going to replace that 1 over there to be this cos squared plus sine squared. Okay, so we get here 3 sine squared x plus sine x cos x minus 2 times sine squared x plus cos squared x. And that whole thing is equal to 0. Distribute the minus 2 in, and we get 3 sine squared x plus sine x cos x minus 2 sine squared x minus 2 cos squared x equals 0. And now I've introduced that cos squared. So now we can treat this as a trinomial. I'm just going to get like terms together. So 3 sine squared x minus 2 sine squared x is just going to be left with sine squared x plus sine x cos x. And then this minus 2 cos squared x. Okay, so you remember my little substitution, make sines y and coses x. Do not get confused with this x, it is not this x. So this thing here would become y squared plus yx minus 2x squared. Okay, and if we had to factorize that, we would get y plus 2x, y minus x. Okay, that gives us y squared. That gives us minus yx plus 2yx, which gives us the plus yx. And then that times that gives us the minus 2x squared. Okay, so now I'm going to change these things back into their trig ratios. So this thing factorizes. Now remember, y's are sine. So this is sine x, x's are cos, plus 2 cos x. That's a sine. Minus, that's a cos, equals 0. Okay, so just like any normal equation, we've got that times that equals 0. So that means we'll have sine x plus 2 cos x equals 0, or sine x minus cos x equals 0. Okay. Let's work with this one over here, because this is very similar to the first example that we did. I'm going to take this to that side, and we get sine x is equal to minus 2 cos x. Divide both sides by cos, and we get sine x over cos x equals minus 2. So that gives us tan x equals minus 2. Take our calculator, shift tan minus 2. Round it off to 1 decimal place, 63.4. So we get x is equal to minus 63.4 degrees plus k 180, because it's tan. And here we get k is an element of the integers. Cool, let's work with this one here. I'm going to take the cos to the other side, and we get sine x equals cos x. Divide both sides by cos. So we get sine x over cos x equals, now cos x divided by cos x is 1. Okay, so we get tan x is equal to 1. Shift tan 1, and we get 45. So we get x is equal to 45 degrees plus k 180, where k is an element of the integers. All right. Bit hectic, grade 11s, but not too bad. Okay, I have seen these types pop up in exams before, so just know how to do them. All right, so for homework, I would like you to do exercise 7.12, number 1, A, B, D, F, G, I, K, and L. Then number 2, B, C, E, G, I, K, L. Sure. Okay, don't worry. We're going to take our time on this, so don't freak out. Grade 11s, what I would also like you to do in the chat, if you click on your little emoji button, you'll see a little dancing penguin. I'd like you to press it on the dancing penguin and put it into the chat for me, please. Thank you.